Welcome back. Today we're starting a new unit on hypothesis testing. Sounds fun, right? This is just an introduction. Now, remember when you were a kid and you were in science class and you were doing experiments and you were trying to make things explode, right? And your teachers introduced you to this thing called the scientific method, and it had all these steps. And you didn't want to go through all the steps, you just wanted to make things explode, right? Well, the steps are important, and the same thing is true in statistics. So in the early 20th century, a bunch of statisticians got together and they put together their own version of the scientific method, and it's called hypothesis testing. Hypothesis testing is the scientific method of statistics. It includes 5 main steps that look like this. Today I'm going to show you the 40,000-foot view of how it works. Step 1 of hypothesis testing is, well, the hypothesis, or in this case, the hypotheses, because there are 2 of them. Our first order of business is to state the null and alternate hypotheses. Let me define these for you. The null hypothesis is notated like this. We say H sub 0. It's also known as the hypothesis of no difference. It's an assumption that's being made, but it's also an assumption that's being tested. And it always has the equal sign somewhere in it. The next hypothesis is the alternate hypothesis, and we note it like this, H sub 1. It's the complete opposite of the null. It covers whatever ground the null hypothesis didn't cover, and it's the conclusion you come to if H sub 0 is found to be untrue. This will all make sense when we do an example. Moving on, the second step of hypothesis testing is to determine the level of significance. This step is awesome because it takes less than 10 seconds. If you're in a statistics class, this is usually just stated in the problem, and it will likely be either 0.1, 0.05, or 0.01. 0.05 is considered the industry standard, so when in doubt, just choose 0.05. On to step 3. Yeah, remember how easy step 2 was? Well, this is the opposite. This is by far the hardest part. And it's a very critical part too, because here's the thing. In order to determine the test distribution, you need to consider so many things, like how many samples you're studying, if you're looking at a mean or a proportion, if you know the population standard deviation, how large of a sample you have, do you have dependent or independent samples? I could go on. This is the part that leaves people scratching their heads, and there's no way I can cover every possible test in this video, let alone in this class, but I will give you a hint. I found it extremely helpful to make a decision tree of sorts for myself, like this. It gives you a great overview of what tests are available and when to use them. Step 4 is to define the rejection area. This is where we draw a line in the sand between what we'll reject and what we'll accept, or in statistics speak, we say fail to reject. The rejection area is based on the level of significance and the test distribution. And it should start with the words, reject the null if. Again, it'll be helpful to see an example on this one, so hang in there. Step 5 is to do the math. Finally, this is the fun part. And it's kind of like making the explosion finally happen in science class. And once you've done steps 1 through 4, this one's easy. We'll work through each of these above steps in a future lesson. So there you are, your introduction to hypothesis testing. If you're a bit confused, don't worry. We're going to work through each of these steps in subsequent lessons. I just thought it'd be nice to have an overall framework so you have a place to put the information when we learn it. Thanks for being here.